Hello everyone, I'm Xiao Gang. Okay, in this lesson, we'll work on the movement part of the input mapping. Then we'll go to our character section and we'll start pasting directly. You can follow along and paste with me, no problem here. So, how do we paste it? Everyone, here, it actually creates a config file for games, meaning the information here can be configured. You don't need to worry about this. And here, it also defines a log. This log is a log specifically for writing character logs. So let's change it to, since this thing exists, let's get it done as well. This is the log. We're already very familiar with it. Then when we're at the top here, we declare the log. So we need to define the implementation of this log. Yes, you can follow along with me, because this is all quite simple. We'll just give him a demonstration. So at this point, we need to start performing some operations on our edge quantities. First, we need to prepare a preview hand. This arm pointer points to it. Then we also give a pointer for the camera. We haven't created something like that yet. Okay, here we can just copy these forward declarations directly. Yes, just copy them over and leave them. Just put these forward declarations here. And here's what we need to place. These are the input assets that need to be bound. Then we put these assets together. Just put them together. And note here, this is visible 2012. So this pointer is in these places. You can only view and cannot modify it. Over here, it can be modified. So you can make changes. Then, because we know that this permission, when passed down, is actually protected, so in this place, we allow it to be accessed. Then this is its category classification, and this place is its constructor, then begin play. Then here we simply wrote these two methods. These two methods are mainly for obtaining our member variables, because we might use them in other places. Now we need to define two methods. These two methods are protected. We'll just put them under begin play. Okay, these two methods are mainly for binding. We won't write anything for now. We'll just create them. Okay. After creating them, let's start writing from the constructor. Wait, normally, when we write something, we might clear the constructor function. First of all, here in this place, we will adjust its capsule collider. We might not need such a large capsule collider. The reason it shows a red line here is because we haven't included the header file for the capsule collider. Because you are wrapping its pointer here, so actually, we can do it all at once and paste this header file over. For example, it actually uses this header file. You see, this header file includes it. Then it won't show an error. We'll just borrow it from here. We'll just paste it over. Okay, paste it over. Okay. This place, the name of this emitter at this location, we just need to change it. Because I think we've written many lines of code. These are all routine operations. Right. After pasting this, let's move on. This part is to modify the size of the capsule. Then we create here the actual camera component. Then create it with this name. Then attach this camera to the capsule and also modify the relative position, and also use this controller to control its rotation. Then at this point, let's continue to create our actual scanner mesh component. After it's created, we attach it under our camera. Then we just turn off its shadows and such. As for this tick, we can ignore it, because probably doesn't need teeth. Okay, after this is done, we set its relative position. This is its own comment. Maybe adjust it a bit. Feel this position is more suitable. Right, okay. After doing this, let's continue looking below. Then we mainly look at this binding method. As for this method, we can take a look here. We can look at the parent class. The parent class is actually useless. It's just a check. To ensure the passing component must exist. Actually, whether this parent class exists or not, it doesn't really matter, but we must use the enhanced input context. The enhanced input component must be present here. If the conversion fails, we can print a log or set a bang. Because if it fails, it's clearly wrong. That means your project hasn't configured enhanced input. Yes, you need to check this setting. And this part, that is through some reflection, we write it down. That is, the enhanced input component cannot be found here. This one is really quite long. You need to update the C++ file, or you are using the old input method. This part retrieves this name. Okay, good. So if we can successfully get it, then we bind this jumping action. Input action. It has several activation methods. this kind of stat always active. Then when activated, you can test this by writing a blueprint. This is a piece of blueprint knowledge. That is, when it triggered, some of them will keep triggering. That is, if you hold it down, it will keep running. Some trigger on release. Some trigger on press. Some trigger after the entire operation is completed. So this tool is designed with that meaning. You need to do this more, practice more, and you will understand. Then here, actually, you just need to not recur this trigger. Then for these two methods, we write these two methods. So this binding is done in this way. It is bounded using the action method. Here it must be specified as an enum. Specify which asset it is. Then obviously this asset, we need to specify it in the blueprint. We haven't specified it yet. We'll specify it in a moment. Then the two methods bound. These are methods within the engine itself. We don't need to worry about them. You see, the methods within the engine are left alone. Then this complex movement synchronization is very complex. We know the guests won't talk about this. Regarding this knowledge about movement synchronization, you know there is knowledge in this area. Yes, for your character, after you create it, it can move in the online game, but you can't play animations or use skills. That's because for movement, it is hoped that it has already been done for us. Some optimizations and encapsulations for generation have been made. That's how it is. And now we mainly handle these two event triggers. One is the movement and the look trigger. As for the movement and look trigger, it is mainly written here. So first, the movement code. We directly copy it over. First, it outputs this kind of value. This is a struct because in this place, it has several methods. So in this case, you obtain it in this way. Because this value, it is not clear whether this is a Boolean or a two-dimensional piece of input. Then our controller cannot be null. This controller is carried over from the negative class. It is actually inside Punc. That will be a controller when it is not empty. We add its move component. This move component is also done through this pump. This pump will use reflection to find the movement component, and then here the direction of this movement component and the quantity are passed into it. It drives here, just make it move. Similarly, this look, it is actually the same. It directly goes to add it on the controller. Regarding this kind of pressure value, or an input for the p-value. So basically like this, after finishing it, our character should be able to move. Let's compile it. Okay, let's start it up. Alright, we have started it up. Now we need to find our player character. And here we open it up. Now we need to do some work. We are opening the blueprint. We need to do some resource configuration. Obviously, we can see here, we might also need to adjust some information. We will think about this. Let's first get this input action done. Let's take a look. Here we might need to enter an input. Here there is a jump, and here there is a move. Here there is a look. Good. So with these three things, we can actually move now. At this point, we actually need to also set the Google Grid Mesh here. Configure it. It should be this ons. Okay. We can see this is not right. We might need to adjust it again. Its position. If it's not right, let's check whether we need an animation blueprint to fix this issue. Let's take a look. Indeed, it's because of the animation blueprint. So this animation blueprint might have an issue with its axis. Let's pay attention, because when we import assets, you often see characters lying on the ground. So when you play the animation, it becomes upright again. This is due to the art assets. When they export the assets, the coordinate axes are not correct. When we import them, the axes of the imported assets are also not correct. So this leads to such a problem. So this is because of that. You see, let's distinguish again. This cannot be done this way. Let's undo it. We mainly need to handle this part. Let's adjust it here. Let's take a look. You can see it's like this, proving the possibility of this asset. This axis might be problematic. Okay, then let's ignore the axis issue. Let's see if there are any other places that still need further modification. Then let's take a look. We might need to change this collision here. This collision preset. Let's just turn off this collision. Actually, there's a method for this. That is, we usually these things below. We should not, just these paper-like meshes. Don't change the collision settings. We generally just set one collision for the collider, because setting collision for this paper is actually not very meaningful, because it would instead cause these objects with collision to collide with each other, and they would keep bouncing off each other. That wouldn't be reasonable. There is no collision here. We can see Here we set it to yes. Okay, let's check if there are any other properties that need further modification. Then here we switch to the class default. For this collision, we might need to slightly adjust other collisions as well. For this mesh app, it probably doesn't need to be changed. This one is a character mesh, so it should be fine. And usually this is all set to yes. This should indicate whether this actor can be set up. It probably means whether it can be stepped on. Maybe just leave it alone. As for this capsule, we haven't touched the collision settings here. We just need to click yes. Okay. Then there are usually some other parameters, but we don't really need to modify them. Maybe here's one. He changed some of the default settings. This kind of navigation, or some data like that. We'll just leave it. If you need it, you can modify it yourself. Now let's take a look. Whether our character can move. You can see our character can move, but actually you'll notice it seems the forward, backward, left, and right are all correct. But the turning seems to be reversed. Up and down are correct. Left and right are reversed. So we might need to adjust it. Our map mapping. Here, is it possible that this place might be that's possible? Then we found that this place is wrong. Then let's check the project. It is written like this. It only checked one option here, which means it only checked Y. So it means it only takes effect on this Y. Let this Y value be inverted. We can take a look. Let's try it now. We see this Y is fine. That should be it. If you see this, it's normal. These are some small details. And now this character of ours, actually, he can also jump far. You can see this hand. It's basically fine. We won't go into this animation blueprint because this animation blueprint is not what we're going to cover. The focus of this course is on the animation blueprint. It will hang particularly long